Hi, everyone. Thank you for coming. Today, we're going to talk about whether silver bullets exist. What do we mean by silver bullets? Whether there is a single solution that will solve all our problems. And probably the answer to that is no. So let's start. Okay, so first introduction. I'm Gaby Moshe. I am Senior Director of Engineering at Ping Identity. I manage the MFA, risk and products in Ping Identity.
Hi, I'm Oren Sternheim. I'm a Senior Manager, Engineering Manager at Ping Identity. I've been in Ping Identity for almost 6 years, starting as an application security engineer in the security team, and now managing the engineering of Ping ID.
Okay, so what do we see here? Basically, we see two authentication, biometric authentication systems. One of them is airport security, and one of them is authenticating web flows. And I have a question. You don't need to answer. I'll answer that. Which one of them is more secure, and why do you think it's more secure? So I said, that's a good answer, but probably not. The airport security, because this is a more controlled environment versus the web environment, which is pretty open environment. It's uncontrolled. And if you think about it, when you're running on a web environment and you have a web browser is basically the ultimate remote code execution framework. You get all these assets from the server, JavaScript, HTML, CSS, and the browser just executes them. And although it's a great tool to do innovation, finance, entertainment, and many other use cases, but it's also a great tool for hackers, fraudsters to kind of exploit. And that world is very open and dangerous. And basically what we're going to see in this session is that even the most secure authentication methods, and we're going to demonstrate it through a most secure authentication available today, which is WebAuthn and FIDO, it's still, when running in such an open environment, it's still basically, you can hack it through the environment of web, which is kind of, has a lot of security web shortcoming. Okay. Okay, so what we're going to talk about today is basically, we're going to start by describing the web shortcoming, talk about JavaScript and what JavaScript can do in a browser. And after we understand the vulnerabilities and the shortcoming of JavaScript and what they can do, then we're going to have some short introduction into FIDO. Specifically, we're going to focus around those areas that is implemented through JavaScript to understand how we can take both the web environment, which is many of the implementation is based on JavaScript, and WebAuthn, which is also a JavaScript API, and kind of put them together and see how we can exploit the JavaScript environment to do account takeover over a FIDO protected account. We'll see a demo, so it's not a live demo. It's a video that we've recorded. Oren here implemented that exploit in the lab. And then after we understand how it works, we'll see a demo. We'll talk about some mitigations. Okay, so let's start talking about the web flows and what JavaScript can do. So we have a fictional UPay site here. a web browser of a user and basically a third party implementing ads. Many websites has ads implemented, but it's not just ad. I think most of websites today have much more than one third party included in their application. So basically the way it works is the browser reach out to the website, gets all the assets. In this example, we have two JavaScripts, user profile JavaScript and login JavaScript. User profile JavaScript basically allows you to update your profile, change your address, and do a few other functionality, whereas the login JavaScript authenticates you. Basically, it collects your username, password, OTP, and basically manage the authentication flow. But you also have ads.js coming from a third party because you want to include extra content from a third party, and that's a very normal use of a web application. But the question is, what can that ads.js do? Can it also make the same API calls as the user profile JavaScript does? Can it also collect username, passwords, and OTPs? Well, of course, the answer is yes, it can. It can basically do whatever the application can do, that third-party JavaScript can also do, which opens a variety of attacks that can happen in those use cases. So before I continue, just a few words. This attack where you compromise a third-party assets is called a supply chain attack. And it's basically, if you consider your security posture, and it's basically your security will be as strong as your third parties. You can protect yourselves from government level attacks, but if your third parties are not in their threat model is lower than that, then you will be as protected as your third parties. That's a very important thing to remember. Okay, so a little bit about supply chain attacks. So as you import JavaScript into your application, basically it could be thousands of lines of JavaScript code, it could be cryptic. Trying to figure out what's in there is pretty much impossible. So you really, really have to trust the vendors that and third parties, open source libraries you bring into your application. As we said, could be your weakest link, weakest point of failure. So one example is an open source. If you're not familiar, PHP is an open source project. It's developed by the community, and that's something very important because things that are developed by the community, anyone can contribute to that code base. And in this example, someone managed to merge a commit to get approve on a commit with a remote code execution option on the user agent header. That was approved and merged into the master branch. It was quickly afterwards removed, but that shows where community libraries can be used in order to breach your application, and the controls around them sometimes are not that good. It could happen that those vulnerable code gets into those community libraries, and that will end up in your application. So as we said about like third-party JavaScript, the same is true for browser extensions. So unlike the supply chain, where it's controlled by the developer, and the security team of the application. You could harden your application as much as you want, but if a user installs a browser extension, you do not control that. And that's one of the differences between supply chain and browser extension. But the same things that we said about third-party JavaScript applies to browser extensions. So the same extensions also runs JavaScript in the extension, and it can basically do whatever the application does, as we said before in the supply chain attack, making them very dangerous because it's the end user control. One example to a browser extension is the Great Suspender Chrome extension. That was a legitimate extension that was bought by a malicious group that then changed the code of that extension and weaponized it to do bad things. So even valid extensions could be compromised later and be weaponized to run attacks. Okay, so let's just do a short recap on what we just saw on JavaScript. So basically, JavaScript, third-party JavaScript running in your application can do whatever your application does. And that's something that to take from the previous topic. Now we're going to have a very short introduction into FIDO, but before we begin, I'd like to remind everyone that although we're using FIDO as an example, we chose FIDO as an example because it is the most secure authentication method. So what we're describing here is valid for all the other authentication methods, whether it's push, OTP, SMS, everything could be compromised the same way. We just wanted to show that it's something that is beyond the authentication methods. And it's still, FIDO is what we recommend using as the most secure authentication method. Okay. So we talked about JavaScript, and FIDO running in WebAuthn is something that is running on the browser side. It has a JavaScript API that invokes that flow. It's standard-based, which is kind of one of the advantages. It's accepted by the industry. We just saw the passkeys announcement. Everyone accepts that, and it's something that the industry is going to adopt more and more. It's a secure, phishing resistant, and user-friendly standard. So that's a very secure and very good authentication method. So as I said, this is a browser-based API. So you have a JavaScript that you can see here. Basically, once you make that call in your JavaScript, it will invoke your security key. And the user will basically type in his PIN or do biometrics and authenticate. And that's how it looks like. And that's connected to the previous topic. It's JavaScript based. A little bit about the security principle and promise. This is from the FIDO Alliance site. In terms of security, every site has its own keeper, so nothing is shared between sites, but that's what makes it phishing resistant. There are no shared credentials between different sites. In terms of user experience, there's no media break usually. The user just needs to enter his biometrics or PIN code, and that's it. So very good user experience. And in terms of privacy, there are no PIIs participating in that flow, and no shared identifiers between websites, or there's no way to correlate the same user across sites, so it kind of keeps your privacy. Just the high-level actors in the flow to get the terminology right. We have the relying party server, which is the authenticating server. We have the browser. Between them, the protocol is WebAuthn. And we have the authenticator, and the client to authenticator protocol is setup. Let's go over the high-level flow of FIDO authentication. Basically, we have the browser. In the URL, we type in upay.com. It asks for a challenge. With that challenge, there is the relying party ID, or in short, RPID, which specifies the domain name that we are authenticating to. Then the browser has two main things that it needs to do. One is to validate the RPID. It basically takes what the server returns and compare it with what we see on the browser on the URL. If they are the same, then the browser will now serve as a mediator between the relying party and the authenticator. It will take that challenge, send it through setup to the authenticator, where the user will do a biometric or PIN code. You can see the screenshot of the user experience. The authenticator will then sign the assertion, the challenge, send it as an assertion, and then the browser will send it back to the relying party to be validated. So what makes FIDO phishing resistant basically is the part where the browser compares the RPID with what we see on the URL. If that matches, then the flow will continue. Let's see what happens when it breaks that assumption. Yeah. We'll take the questions. OK. So let's see what happens when UPay change the letter O to the number 0, just to try and do some phishing. And in the RPID, it returns upay.com as the original site. Basically, then the browser will detect it. It basically compares the URL that is on the browser side to what is returned by the relying party server. It sees that it's different, and then the transaction will fail. That's what makes it phishing resistant. OK, now, Oren, do you want to continue?
OK. So as Gaby described, we have web shortcomings. We saw that basically JavaScript running on a page can do anything that the application can do. And we also described FIDO, a quick introduction. So now we are going to demonstrate and explain how web shortcomings can be used to take over any account. So we saw earlier that even if the account is protected with username and password and even OTP, we mentioned push and other authentication methods, but we want to focus about the WebAuthn and FIDO, since it's the golden standard of authentication today. So this is the diagram that Gaby showed on the couple of few slides, first slides. To this diagram, we added the attacker part at the far end. And basically, the attacker, let's assume that somehow the attacker managed to temper the ads.js. That's the supply chain attack, right? He's attacking the third party in order to get to the relying party. So it doesn't matter how he did it, but let's assume he did. And he added a malicious functionality to the ads.js. So now when Edge.js is running in the context of some application, it can do everything as the application can do, right? That's what we said. And now we're going to see how it is able to do also WebAuthn functionality. So let's assume that our application, upay.com, it's embed a WebAuthn.js asset to do all the WebAuthn logic. So you can see in green the fetch challenge, and then there is the user challenge that upay.com produced for the user. So the malicious functionality in Edge.js, what the attacker added to the file, is the ability to catch that event, and just before invoking the WebAuthn API, it will invoke a remote server that the attacker was able to, the attacker controls the remote server, and he will fetch the challenge. You can see the red line going from the relying party, because everyone can fetch challenges from the relying party. He fetches his challenge, and he uploads it to the remote server. Now, the functionality added to Edge.js will fetch the challenge, and instead of invoking the WebAuthn API with the user challenge, it will invoke the WebAuthn API with the attacker's challenge. And upon the screen that will pop up for WebAuthn credentials, the user will provide his biometrics or PIN code. He will have no idea which challenge it is, right? Because challenge is just a challenge. It's a random number. It doesn't belong to anyone. And he will put his biometrics. He will approve it, and we will get an assertion. The Edge.js file will send the assertion to the remote server, and the attacker will be able to use this assertion in order to take over the account. Afterwards, in order to lower the suspicions of the user, Edge.js is going to invoke WebAuthn the second time, this time with the user's original challenge, in order to log him in. So he won't suspect that anything wrong happened. Maybe he will think that it was a glitch in the application. You need to do WebAuthn twice. So let's see the demo of it. I will pause during the demo, and I will give some explanations. So the demo starts on the attacker side. And the screens that you are seeing is actually what the experience for the attacker and for the victim, how they experience the attack and the account takeover. So this is an application that we have built, imaginary application. It uses WebAuthn flow. You can all see here the passwordless login. So when we click the passwordless, it will take us to WebAuthn passwordless flow. The same could have been implemented with MFA, and we actually did it. But we want to show the passwordless since it's more cool. So the attacker will log in with passwordless in order to get a challenge. And then instead of popping up the screens, the WebAuthn screens, you would expect Windows Hello or Chromium screens, it takes the challenge and sends it to the remote server. The remote server then have a valid challenge, and it's waiting for a victim to use it. So let's see how the victim side. So now a victim, just a random user, it goes to the same application. Now, forgot to mention, I forgot to mention that this application actually have a third-party JavaScript, and we also added the malicious functionality to the JavaScript, right? We can't really do supply chain attack on real vendor. It will be hard even if we want to, but we built this demo application. So the victim will use the same passwordless authentication, and oops. And right now, before calling the WebAuthn API, at this stage, it's already happened. the functionality, the malicious functionality in the JavaScript file fetched the remote attacker's challenge from the remote server. And as you can see, the user have no way to distinguish. He can't really tell that it's not his challenge. So he's going to put his credentials, his face, and it says, hello, Oren, everything good. Now he's going to press OK. He will get an assertion. The assertion is sent to the attacker. You can see that the attacker will now log in as Oren. At this point, basically, the account has been compromised. And you can see on the victim side a second attempt to invoke the WebAuthn API with the original challenge, and the user is logged in as well. OK, we will run this one more time without talking, and just so you can get the full experience end-to-end. So first attempt, logging in the attacker. And second attempt to log in the user. OK, so I hope you understand the gist of it. Let's talk about mitigations. So this slides contains a few items that we thought that could help mitigate the attack. There are obviously other things, but the main thing that we want to bring up is that use layered security. Layered security approach, we didn't invented it. It is always good to have, and it can mitigate parts of the attack. I will go through the bullets and give a bit more details about them. So the first one is risk and bot detection. And let's discuss bot detection first. So in order to deploy this attack on scale, the attacker side will need to be automated. And how it can be done with tools like Selenium and others that can do the attacker side in such an automated way, harvest more and more challenges, more and more sessions. So there is always a valid session waiting for the user to use it and to compromise an attack. Then I can create a database, post it in the dark web, and maybe sell it for a lot of money. So if I have bot detection, that basically blocks me as if I want to deploy this attack at scale. And actually, that's what happened to us when we implemented conducted the attack. Sites that had bot detection, we couldn't run automation on them. Let's talk about risk. So in risk, explicitly there is velocity rules that will detect anomalies. So the first one is geovelocity rule. If the attacker is conducting this from a remote location, probably he will, geovelocity rule will indicate that there is a large distance between the two authentication attempts that happens usually in a few seconds or minutes. And it might be able to block one of them. Probably it will be the user, but at least the user will call help desk and say, hey, something went wrong. Maybe someone can check, and then you can do incident response or whatever. If the attacker will try to get closer to the victim by using some sort of a proxy or VPN, so risk have also IP reputation rule that can detect those and block them. Also IP velocity rules. So the attacker side produce a lot of traffic. This will probably trigger anomalies and high risk authentication attempts. And if you're monitoring the authentication events and the risk level of them, you will see a trend of high risk events, and probably you will act upon it. Okay, the second bullet is supply chain review. So we are not going to give you best practices on how to do supply chain review. There is NIST and CISA documentation on how to do this. We really recommend Googling it. And we're just going to say that you really need to do supply chain review. You need to be aware when you're adding new software vendor or open source to your application. As Gaby mentioned before, your security posture goes as far as your suppliers does. So use that, and there's also automatic tools for scanning software packages, right? We are not going to name names, but there are a bunch of them. There are good tools, but we identified a gap there where they are not actually scanning for, or at least some of them, not scanning for HTML imports. So if you have an HTML file and it imports a JavaScript, automatic tools that you put on your CI/CD to scan your software packages, some of them won't catch them. They catch Java packages, Node.js, but not JavaScript imports. The next item is to update your threat model. So if, for example, in your threat model, you're trying to protect against nation-state actors, you want to verify that the entire vendors on your supply chain also have in their threat model supply chain nation-state actors. This is also connects to the point that your security posture is as good as your vendors in the supply chain. You may also want to add this type of attack to a threat model that you're conducting. Next bullet is more of a best practice when and if you're implementing WebAuthn. You probably would like to have a dedicated subdomain for authentication. So in our example, it will be auth.upay.com. And in this dedicated subdomain for authentication, you would like to have less vendors, less being dependent on relying on third-party JavaScript. If your application in general needs to put ads or puts any additional functionality need to be taken from third party, it will just isolate the authentication part. And when implementing WebAuthn, you would like to specify in the RPID the full domain, the auth.upay.com, because you can specify only upay.com, the parent domain, but then it won't be isolated. So you want to create this isolation, and not only for authentications, also for other sensitive parts of your applications, like payments, like change address, account management, change password, those kind of things. Okay. Next bullet, and this actually forgot to mention it on the first slide. So we saw that third-party JavaScript, well, we discussed that there is a supply chain attack, and the attacker managed to tamper the ads.js. But the same attack can be conducted by browser extension. And there, instead of performing a supply chain attack, as we mentioned before, the user control whether he installs a web extension or not. So a web extension can also do the same thing, since there is JavaScript running on the same application, and it can perform exactly the same attack. We've actually also demonstrated it on our lab. So when it comes to mitigations, you probably heard it a million times, right? Browser extensions, they have enormous power. They can do a lot of things. So this is another reason why you want to be aware of browser extension and install only ones that you really trust. Now, if you're a CISO in the organization, you might want to select or whitelist, if you can control it, which extension you allow to install and which extensions you don't allow to install on a managed browsers. And maybe even better than control is to educate your users that extension can be dangerous, and you should be aware of that. Okay. Let's talk about possible future enhancements. So we have created an issue in WebAuthn, GitHub bug tracker, and one of the options that were suggested there is to use the content security policy header, also known as CSP. So CSP has directives. It's a response header, HTTP response header, and it basically tells the browser you can load assets from this source or this source. As we envision it, there will be a new directive that will specify exactly from which resource we allow to invoke the WebAuthn API. So if there will be a invocation happening from resource that wasn't specified in the content security policy header, it will be blocked by the browser. So it will be interesting to see this maybe in the future, maybe if WebAuthn will work with W3C workgroups to implement it. Next thing is extension store. So browser vendors, all the biggest ones are, they have extension stores. This is a marketplace. I believe that most of you know them. You can download extensions from there. And those vendors, Google and Mozilla and Safari, they're giving a lot of effort to audit the extensions and take down malicious extensions and keep the marketplace with extensions that can't harm you. So we suggest to them, if this is a shout out, if they will hear us eventually, to audit based on WebAuthn invocation. So if an extension calls the WebAuthn API, it should have a good reason why to do so. Perhaps it's a password manager that could be reasonable, right? But if it's a QtKitties extension, I will struggle to see the necessity to use the WebAuthn API. Okay, last slide, we want to come to a conclusion. So we started by looking at web shortcomings, and we explained that all authentication methods suffer from the same web shortcomings. This is what we showed today isn't an issue in WebAuthn itself, but in the web architecture as a whole, which was performed tens of years ago. WebAuthn is the golden standard for authentication, and you should use it. It's a great authentication method. And I guess the last thing that we want you to take from this presentation is that use layered security or security in depth. That's always true. And that's it. So thank you. I appreciate the time. If you have any questions.
Yeah, now is the time.
So basically, this attack is that the user essentially authenticates twice.
Yeah.
And that's really, so from a user perspective, you should suspect that, right? But we know users don't suspect anything.
They don't. I can tell you that when we did it in the lab, Oren sent me a link. I authenticated. I didn't know he kind of tampered with that page. So I didn't really know. I just approved it. It asked again, so I didn't put too much thought into it. And I knew that is what we're doing. Yeah, so people will never know this. Sometimes you click a button, it doesn't respond, you do it again. That's the same experience. It happens so fast that you don't know even if when you're using Touch ID, you don't really know if you clicked it correctly or not. It asks again, you don't really notice it.
Yep.
Have you seen that attack somewhere in the wild, or right now it's more of proof of concept?
We didn't see it in the wild, and we also don't have visibility to the entire web, right? So it will be interesting for future research to take this and kind of study it and maybe explore if this is happening.
We did test it across the industry, and it is there. So it's a matter of hardening the web environment, and that's why the question is, the title of this session is, do silver bullet exist? And you can't really go into a false sense of security when implementing a strong authentication system, because it's a strong authentication system, it does not harden the web environment. And that's really important takeaway. It's a good authentication system. It does not mitigate all the shortcomings of the web environment.
I know this is just one mitigation of many you mentioned like the geovelocity.
Mm-hmm.
And I thought it was interesting that in this attack, it was specifically the user that would be logged out,
Yeah.
not the attacker.
Probably,
And
yes.
so in my mind, I'm thinking about the workforce and the consumer use case, where, I mean, at least in the workforce case, you could have an instant response that just sees that maybe you do or maybe you don't block the user from logging in, because it actually was them that was logging in. I don't know how you do that for the consumer, but I'm just wondering what your thought is there.
So
Incident response is the critical part of this.
that's a good question. So maybe in the individual, you will not notice, or you'll not know. But if such an attack happened, it will not just happen once with an individual. It will probably happen at scale. And once you have those tools, you will see an increase in those. So in any risk system, you have analytics, and you can see the trends. And if you see a trend of a spike or spikes in risk level going up in all sorts of predictors like geovelocity or IP velocity, there are many velocity rules. Many of those rules will be triggered by this kind of attack. So you will be able to at least know that something is happening. If you have no tools to see those happening, you will not even know about it even. Yeah, John.
Essentially, it's blocking the features, but it's really looking at the pattern and saying, this is happening a lot.
Right. Yeah.
And it didn't used to happen, and it's something that we see now a lot. Let's see what's going on. And tools like bot detection, basically all these kinds of attack that requires automation will be blocked at scale. You can't have one person or even group of people doing that at scale. It's very hard. It's possible, but it's very hard. You would automate it, and bot detection will probably block. And we've seen some vendors do that, and we were blocked. Yeah.
Yeah, so we didn't actually conduct a full research on it. We just noticed that some package scanners doesn't pick that up and doesn't scan HTML at all, right? Again, some of them, maybe there are ones that do it. But basically, if you have an HTML page, you add You have a script element, right? You know, the markup language, when you do script and then source equals, and then you put the source. Now, it can be a relative path to your application. It can be a path to a third party, right? So maybe you would expect that the scanner will fetch the remote code, and it will scan it as well. But that's also an issue because the code can change. So you do a deployment, you put your code in production, and then the JavaScript changes. So it's not straightforward. It's really hard to do this in a very efficient way.
So if you're implementing a third party and you're kind of linking to them in runtime, if they change it, you do not control it. If someone compromises it while you're already in production, you don't know it.
And so this is something that we need to look for as part of the vulnerabilities that we know that we bring a vendor to make sure that
You need to trust your vendors. If you bring up an open source, arbitrary open source you found on the web, and you bring that into your application, you should be careful about doing that.
Is it possible to potentially block this attack with cross-origin requests?
What do you mean cross-origin request?
Cross-origin request scripting, CORS?
Oh, CORS. So CORS is actually a mechanism to whitelist requests, right? So by default, they are blocked. When you put the CORS header, you allow the application to fetch a remote location. So I don't think it will be, but
So in that case, your advertisement that code extension will not be working, right? I'm not talking about disabling code, just using code rules so that the domain doesn't change.
It doesn't change,
Oh.
but you also list, you want to allow, you think about it, you want to allow, you explicitly imported those third parties into your application, so you would allow them. And if they are compromised, then you're compromised. If you block them, then you cannot really use them. So if you're bringing ads into your system and you're using some ad vendor, you will allow it.
It's the ads scripts that I'm thinking that you might be able to block.
you want it in the application.
you want
the
the ads.
functionality. Yeah.
Any script.
Any script.
So pretty much every website
Yeah.
you'll go, you'll see those cross-origin scripts. Even we looked at government sites. You will see them in kind of everywhere.
Those ads, those JavaScripts have to come from that origin to be able to execute in the context that
Yeah.
Yes.
they can't come from a previous site.
No.
But the browser extension could
Yeah.
Yes.
work in the context of all browsers.
All browser, all sites, everything. Yeah.
Absolutely, yeah. And this is actually how we managed to test it on sites that are we are not external to our lab.
Yeah. Like
We use the Chrome extension to do that.
Any other questions? No.
The first
Yeah.
slide?
It will be your, that's the thing. It will show whatever you logging into. So you will not see anything. There's no context of like the location where you got the challenge from. There's the context of, hey, you need to sign this this assertion. And you expect it because you're logging into the site.
They are not
But there is no, it does not exist today in the standard. Yeah.
Okay.
Okay.
Thank
Thank
you
you,
very
everyone.
much.
Hope
If
it
you
was
have-
interesting.
Yeah.